Okay, I have to go through a lot of principles of perspective with you, like ellipses, inclined planes, and all these things. But I also want to try to, as much as possible, tie things into stuff you would use perspective for. So one of the things is drawing figures. There are a number of applications for perspective in that. Another is, well, drawing vehicles, you know, spaceships and cars and things of that sort. Drawing buildings and, you know, to some degree, things you might do in landscape, like hills and roads and all that stuff. And but today it'll be mostly about drawing people. So it's not just per se for drawing people themselves. Also, when you draw scenes or scenarios, you like to be able to put people in them and have them kind of make sense, you know. And so, a number of reasons for doing this. Move this over here. Okay, let's just look back quickly at the kinds of perspective that one would want to draw. So I don't know if this is going to be dark enough. That's not bad. Let me try this one out here. Yeah, that's okay. Not my favorite kind of pen, but it's all right. So underneath each kind of perspective, there is a grid, kind of a conceptual grid. Sounds awfully hard to understand when you use words like that, but it's basically a set of rules stated in the form of lines. That's all it is. So we have something called 1 point. If I go off the edge of the paper or off the edge of the planet, just let me know while I'm doing this, because sometimes I start drawing up here and the paper moves, but just sing out if you would. So there's 1 point, there is 2 point, there's 3 point, there's something called fisheye, and there's something called cylinder. Okay, so each one of those has its own way of organizing the world, okay? And that's the grid that's under each of them. So under 1 point, you have a grid that looks like this. You have a horizon line. You always have a horizon line, H, and you have a single point there. So out of that horizon line, out of that single point, you have a number of fanning lines that come out from the center, like this. Now you also will have two other kinds of lines. You'll have a set of verticals and a set of horizontals. And they can be anywhere, not just where I'm drawing them, and you can draw your lines on there anywhere, not just where these grid lines are. They're just showing you a general guide. So with 1 point, you can draw stuff like this. I can once again set up my point there. And is that in focus enough there? I don't know if it goes any better, but it's maybe a little better. Supposedly automatic focus, so it is what it is. Okay, so we started out again here with the horizon line, and then I could draw stuff like just wacky stuff like this, and I could have it extrude. So that's what we call a profile. A profile is a shape that we can extrude. It's like if you have a profile of aluminum on a window, well, they extrude that, you see, when it's hot somehow, right? So we do the same thing, except it doesn't get that hot. So we draw every little change in direction, see, toward that vanishing point, and then we chop that clay off so that it looks like a three-dimensional object. Right? So that can happen anywhere. It can happen down below, it can happen up above. You can have an aerial view, which would happen if you were drawing something down below. You can have a ground level view, if you were doing something that crosses the horizon, like that. We call that a ground level view. And when you look up at something, we call that a worm's eye view. So you have those three possibilities anywhere on this page in relation to the horizon. Now you notice I don't have really any verticals here except one or two, and I don't have any horizontals except maybe this one and this one, right? So when I say this set of rules gives you three possibilities, it doesn't mean that there are only those three. You need the three possibilities to set up the grid, and any one of these things with organic looking strange shapes could fit in a box. See, I could draw a box around any one of those shapes. It's the box it came in. So the little conceptual trick is to draw the box the thing came in. When you want to draw something organic and complicated, you think of it as fitting into a box, and you construct the box, and that will give you the general direction and placement of lines. See, so here there's a box there. I can set up a box here and go back towards the vanishing point like that. So it's as if it arrives in a crate, and what you do is chop one of the ways of looking at it is you're chopping away clay away from this cube of clay. See? Same thing with that one up there. So why is this the case? Why do we use boxes to do this? It's because a box is about the simplest shape that you can make with perspective. You can do things like make a grid on the ground like this, and then come across, see, straight across. And so what would you do with that? It's like a magician's hat. You pop up from the grid and square it off and draw to the vanishing point like that, and then cut it off again. See, so you can create a box by popping the grid up off the ground. So it's pretty much the simplest shape that you can make using a set of straight lines. Now, notice I said that there were three kinds of lines in this grid, and the reason is that what you're doing is you are locating points. See, these are just points in space, and I would include that back corner inside there. So this is a wire frame box that you can see inside. I usually call it an aquarium or a glass box. You see, you can see inside it. But those are points in space, and what you're doing is locating points in space and then connecting them. So it's like if I wanted to locate the end of my pen in space, I would tell you how left and right it was. I could tell you how forward and back it was, and I would also tell you how near and far it is. And once I told you those three things, you would know exactly where this is. It's like in grade 10 math, X, Y, and Z axis. But fortunately, you don't have to think about that because this little system takes care of it for you. Okay, now those have something in common. They're all objects. They're all forms. They're positive forms. You can also draw spaces with one point. So a space would look like this. I'm just drawing, say, the back wall of a storage container, which is costing me way too much money. And it's back there. And then I go horizontally, and I will go up like this. See? So there's a rectangle in the back of all of these. It's in the back because it's being overlapped by these objects. Then I use this vanishing point to bring forward the corners of this theoretical container. And notice that to draw this line, I had to draw these two lines in dotted form to find that location behind this object. And then I was able to use the vanishing point to bring a line through here, see? So that's a little thing that you get used to doing, which is seeing things in 3D form as a wireframe so that you see the far side of things that you normally don't see. You think about the far side. So that's the essence of one point. You can draw rooms like this. You're mostly looking at flat planes that face you, or major planes that face you flatly. In this case, all of the frontal planes of these objects and the rear wall of the room, they're all facing you. And that's what allows us to use the single point to draw the corners, let's say, of this room. Okay, so we can draw a window back here if we wanted to. I can draw a rectangular window there in the back of this storage container, and I can give it a thickness, give the container a thickness going back to that point like this, and then chop off that thickness, you see, and so that becomes it's showing us what's called a reveal. It's revealing the thickness of the wall. In buildings, we call those reveals, like a groove or a thickness. Like that window sill there, you see the thickness of that wall there, right? Looking through that window. It's called a reveal.
Sorry, it's just getting hard to see that middle thing. So the middle window that you drew, it has a square and then another square inside of it?
Yeah.
Okay.
And the corners are going to this vanishing point.
Okay.
See? It's like a tunnel, but a very short one. Okay, at the sides of all of this, and really at the top as well, I could put another rectangle by drawing two verticals, another window. So I've just drawn two verticals there. I'm not off the edge, am I? No. There are two verticals, and then I can take the top and bottom to the vanishing point, but I can do one more thing. I can take this original square and take it sideways until it hits the corner of the wall back in there. So in other words, I'm drawing two parallel lines from the top and bottom of this rectangle, the bigger one, until it hits the corner of the room. Then I use the vanishing point to run through those 2 points, see, like this and like this, and then I just extend these up. So what that has done is it has reproduced this first box that I drew on the inside plane. It has reproduced the size of that, at least up and down, on the side wall. See? It's as if I painted a band on the side wall. See, like that? It's as if I painted a band around the side wall and moved this window to the corner and then moved it forward by using this vanishing point. And of course I could do that on four sides, well, two sides here. Just go sideways here into the corner, use the vanishing point to come out like this, and then I can put the window, let's say here. I can even overlap that box with it like that, which creates even more of a sense of space. So that one is the same size as this one, really. It's not the same depth necessarily, I'm guessing at that. But I could actually make it the same depth by doing this. I could come down with this depth here, come down to the floor. I could come across the floor. When I hit this corner, if I hit it in the right place, I can come up. See, and that would actually give me the same depth as this. So it always reminds me, I don't know how many of you ever had played with an Etch-a-Sketch when you were a kid. You had two little knobs and a silvered glass, and there was a little stylus in the back of it that moved around when you moved the two little knobs, right? Well, it's kind of like that. It's a system. And you could even come up to the ceiling, see, like this. Like that, like that. You could come across the ceiling, and if you drew it all nice and carefully, you could even take, so you're locating a zone in which a skylight might be, up there, and I can even take that back window up to the ceiling, if I had some reason to do that, and then I can use the vanishing point to take it across the ceiling like this and like this, see? And it would actually give me a coordinated rectangle. It's coordinated with the back window and with the two sides, you know? So that is something that you do quite a lot, not put three windows in a room, but move things around that way in using one point. And that is called displacement. When you have the size of something in one place, you use the vanishing points and the lines within the system to move the size of that into other places. Now, there's one thing that I haven't explained at this point, I'll get to it later, is how you figure out the depths of things as they go back in space. Because obviously, a foot out here, like 1 square foot, which I'm just guessing at, 1 square foot out here is not going to be the same size as 1 square foot back there. The sides of it are easy to figure out. They go to the vanishing point, but the depth of it is going to be different because things diminish as they go back in space. So that is called diminution, which I mentioned last week. So there are several things here. One that I brought up last week, which are cues for depth in a drawing. They're visual cues that make us think we're not just looking at a flat sheet of paper, we're looking at some picture that has depth. So those three things are overlapping, diminution, and convergence. Okay, so in this picture we have overlapping, because this box, let's say, is overlapping the corner and the window. We have diminution, repetitive objects that get smaller as they go back, and that's what I just showed you with this square foot thing here.
Sorry, what was the third word?
And the third word is convergence. So convergence is when I draw a grid on this floor. I'll just come down here and draw some segments and then use the vanishing point, see, to draw lines going back, which of course I could do on any of the planes. See, that's convergence. Convergence is when parallel lines move away from you. As long as they're parallel, as long as they're moving away from you, they will appear to converge at a vanishing point. Okay? That vanishing point will be on the horizon unless these little rectangles are not horizontal. See, they could be tilted. They could be tilted up or down. So I'll take one of these things and tilt it up, one of these rectangles. So here's what you would do. You would draw a line through this vanishing point. See? Take a line up like that, just a construction line. And then I would take the angle I would like to see. I'd like to see like a little wedge shape over here. So I'm going to take this angle. It's just an arbitrary angle. I'd like to see that rectangle tilt up. So once I draw the angle I want to see, I take it up to that line and I create a temporary little vanishing point on that vertical line, and that is the point that will let me come back to the other side of this rectangle and draw the other side of it here, see? So there's the two sides of a wedge. I'm coming straight up now, and then I'm coming across, and there's a tilted up little plane on the floor. I could tilt it down by, I'm going to take this plane here and drop it down into the floor. So I would just take my trace line or my construction line downward anywhere like that coming through the vanishing point. Then I will draw the angle I'd like to see, which is maybe that one, doesn't matter. Once I draw that line, I go to that construction line, and then I can bring this vertical line down and come across, and then I'm just going to shade this and shade that one a little bit. See, and now that plane is going down, it's tilted down into the floor because its vanishing point is below the horizon. We'll be coming across this again. I'm just showing you that we can draw tilted things in here, like a drafting board tilted up, that kind of thing. Or the tilted things you usually come across are, well, barring drafting boards and that sort of thing, they would be roads that go up and down hills. They would be stairs. because stairs are just ramps with teeth on them. So you need to know the slope of the stairs, you see. So that's a tilted plane. And also roofs, pitched roofs are tilted planes also. So those are the typical places that you come across them, but not the only place. So at any rate, notice that if I take this box, this room, and I draw the outside of it really dark, just use another pen here. If I draw the outside of this thing, like I extend these corners, draw the outside hitting the corners that I brought out and down, see, and across. Notice that that's just another box, see? The room itself that goes back here. Where did I go? Here. Messing it up here, but get the idea. That is just another box. Usually we vignette, we allow these lines to disappear and just let the lines fade out. We do that more often than we do this. But you do, in fact, draw things like this also. So that is, give and take little tiny refinements of things. That is one-point perspective. Now, I didn't mention the reveals of the windows at the sides. They go directly horizontal like this, see, and then down. So there's the thickness of the window, and then you use the vanishing point to take the outside of the sill and the header forward, see, like that. So now that window that I originally drew there, and even though in the top it would go straight up and come across, showing the reveal, then use the vanishing point, the horizon vanishing point, to draw those two sides there, see? So each of these windows become, see right now it's like a painting on the wall, or a mirror on the wall. If I want to push it into the wall to create a window, I have to draw these little sidekick lines here, and then I need to know the thickness of the wall, and then I use this horizon vanishing point to draw the header and the sill, and I can throw a little shadow down here, and I can also see the horizon outdoors. See, this same horizon is the horizon outside. That's a palm tree. See, so the horizon is the horizon, outside or inside. But I'll mention one thing about horizons, which I did last week. The horizon that we see when we look at the ocean, as long as we're down in our normal reality, on the beach or on a cliff or even in a plane, that horizon is the same as the horizon in a picture. It coincides with the horizon that we use to draw stuff, like right here. But if you go up in a space shuttle, that horizon will drop away until you see the curve of the Earth. But if you want to draw what's inside the space shuttle, if you want to draw the control room and so forth, you have to create another horizon. The horizon is the eye level of the viewer. On Earth, it's the same as the horizon on the ocean. But when that is not seen, you still have to create a horizon which is the eye level of the viewer. So your eyes will think that you are, I'll just draw a couple of eyes here, they will think that that's you. This drawing will think that those are your eyes right on the horizon level. So that's our definition of horizon in perspective. Horizon is the eye level of the viewer. See, because if you are the viewer, you think you're looking up at anything above the horizon. You're looking up, that's the ceiling. You think that you're looking down at anything below, that's the floor or lower part of the wall. You'll think you're looking directly straight ahead at anything that crosses the horizon. Okay? Just the way it works. It's pretty cool. They had this figured out about, I don't know, year 1200 or so, you know? It's quite, you know, they had rocket scientists back then. They just didn't have rockets, so they worked on this. Although in China they had rockets, but you know. But they didn't have perspective. They had something called aerial perspective. They had a different little system. Okay, so that's 1 point perspective. 2 point perspective, its system relies on a horizon which has 2 points. You can create a grid by drawing lines that converge at the left-hand point, converge at the right-hand point, crisscrossing the first set like this. And recalling that I said you need 3 kinds of lines, the third kind is a true vertical. And when I say true, I mean parallel to the edges of your paper, truly vertical, like that. So this one, here's our, I'll draw it up here. I'll just offset these things so they don't take up too much room. This is sort of in review anyway. So here I can draw a box. I'll draw it out here by drawing the leading corner, the corner closest to us, by drawing infinite walls. That's lines that go towards the vanishing point from the leading corner. And then I chop off what we call the extents. How far do they really extend? What is the extent of those walls? Here's one. And they don't have to correspond with the verticals that I drew. I can draw this one in a little closer if I wish, right here, like that. Now, you form a habit of, as soon as possible, thinking, what's this thing like transparently if it was an aquarium? We don't know what it is yet, but I'm going to use the right and left vanishing point to do this. Going to the right vanishing point, crossing over to the left, and then connecting through the back there. So now it looks like a glass cube. Okay, so it doesn't take long to do that, and you just sort of learn to think that way because it saves you trouble depending on how complicated this thing will become. Okay, so that thing can be a closet. It can be I don't know, it could be a giant chair, you know. It could be all kinds of things. It just depends on the scale. It could be a building. It could be a high building with the roads going this way and this way. So that becomes an intersection. And now I can have tiny little people here walking around. I can have a row of trees here. The bottoms and tops of them will be governed by this vanishing point. Then I just put wiggly circles on the trees, see? So basically that could be a building. I could put a number of stories on the building, so let's pick a number. This can be, say, 11 stories, so that means I'll have one, it's an odd number, so I'll have one spanning the middle, and then I'll have 5 and 5, that makes 10, and so I could take those dots in the corner to the vanishing points and draw the floor levels. Now this is something special. It's called a vertical scale. And we didn't really find one in this other picture, but the vertical scale here would usually be that rear of that inside wall there, you see. You would decide how high that ceiling is, and let's say it's a 9-foot ceiling or 8-foot ceiling. Then I find the middle. I divide it, if it's 9 feet, it's an odd number, so there's one spanning the middle, and then I would need 4 on above and below it, see, like that. So that would give me 8 feet. I can move those 8 feet by displacement around the back wall. I can move it around to measure, and the side walls, I can move it around to measure things, see. We'll get into that, but the issue is vertical scale. It's a thing you need if scale matters in what you're doing. It usually does in perspective. So then I've got all these little dots in the corner, so I take them to the right-hand vanishing point like this. They become flat at the horizon. Then they go upwards. Then they wrap themselves around the face of the building, become flat again at the horizon, and then they tilt upwards towards the left-hand vanishing point. And I could do things like put some vertical structure in there, couple of three lines, whatever. Okay, so pretty simple slab-like building, many of which you would find around Vancouver. And so the scale is whatever you want to make it to be, but once you create that vertical scale, then that is the scale. So this thing could be a real building. It could also be a model of a building. That model could be sitting on a table. I'm just going to draw the edges of a table here using the vanishing points like this and going across here like that. So that could be the top of a table. I can drop vertical lines down like this, thicken up the table, and turn these into table legs, see? And so this is a model now sitting on a table. I can even determine the length of the table legs, although it's getting very distorted by now, by drawing a line from